at 8.2. So we're adding this little piece in after 8.2 because it goes with it. All right, so our goal today is to understand that functions can be linear, which is everything we've been looking at so far, or they can be nonlinear. So let's define what that is. A nonlinear function is a function that is not a line. Now, it's still a function, so it still has to pass the vertical line test, but the overall graph will not be a line, okay? Increasing function goes up from left to right. Right? We read from left to right, so when we talk about increasing or decreasing, we have to look at the graph from left to right. So increasing goes up, so it's going to look something like that, right? It's going uphill, okay? Decreasing function goes down from left to right. So an example of that, we could draw a linear function, right? It's going down from left to right. So that would be a decreasing function. Now, as far as graphing these, nothing's changing. So we still have to have y by itself, right? And then we're going to plug in these numbers for our x value to figure out what our y values are. All right? Now, this is just an x, so it's just going to be a line. So plugging these numbers in, I would have negative 0.5. X, the first x it gives me is negative 4 minus 1. Now, negative 0.5 times negative 4 is positive 2. Minus 1 would be 1. Okay? Negative 0.5, x is negative 2 now, minus 1. Well, negative 0.5 times negative 2 would be positive 1 minus 1. 1 minus 1 is 0. So I'd have negative 2, 0. Okay, plugging in 0, I would have negative 0.5 times 0 minus 1. Well, anything times 0 is 0, so negative 0.5 times 0 is still 0 minus 1. 0 minus 1 is negative 1. So it'd be 0, negative 1. All right, I'm running out of room, so I'm going to have to erase my work so I can start over. If you still needed that work, just rewind the tape a little bit. Okay, plugging in 2, I'd have negative 0.5. Now x is 2 minus 1. Negative 0.5 times 2 would be negative 1 minus 1. Negative 1 minus 1, they're both negative, so I actually add the numbers, and my answer is negative 2. Plugging in 4, so now I have negative 0.5 times x, which now is 4, minus 1. Well, negative 0.5 times a positive 4 is going to give me negative 2, minus 1. And again, they're both negative, so I actually add the numbers, and my answer is negative 3. So now I have to graph these points. So negative 4, 1 is going to be left 4, up 1. Then left 2, stay. Then stay, down 1. Then right 2, down 2. Then right 4, down 3. Then we connect the points with a line, because x is just 1x. So connect them with a line, and I end up, it's going down from left to right, which means the function is decreasing. Decreasing. All right, if you have any questions, take your video along with your notes and go up to Miss Benjamin, and I'm sure she could help you figure it out. All right, let's look at a nonlinear example. So I know that this is going to be a nonlinear because I look here and x is to the third power, and we've never looked at x to the third power, which means it's not aligned. So we're going to draw a curve through the points. It's going to be nice and curvy and flowy, not a line. All right? So, but you start off the same way. So I'm going to start by plugging these points in for x. Okay? So I'm going to have x is negative 2 to the third power minus 2. Negative 2 to the third power really means negative 2 times negative 2 times negative 2. So negative 2 times negative 2, that's 4. 4 times negative 2, that would be negative 8. And I still have a minus 2 at the end. So negative 8 minus 2, that's going to give me a negative 10. All right? Plugging in negative 1. So I have negative 1 to the third power minus 2. Well, again, this third power really means negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1, that's 1. 1 times negative 1 is negative 1. And I still have, don't forget about this minus 2 up top. So negative 1 minus 2 is negative 3. So I have negative 1, negative 3. Okay, I'm going to erase my work now. So if you still need it, go ahead and pause. Okay? All right, so looking at the next two then. So first I'm going to plug in 0. So I'm going to have 0 to the third power minus 2. So again, this third power means 0 times 0 times 0. Well, 0 times 0 is 0. 0 times 0 is 0. And I still have this minus 2. So 0 minus 2 is negative 2. Okay, plugging in 1 for x. Now I have 1 cubed minus 2. 1 cubed again, that means 1 times 1 times 1. 1 times 1 is 1. 1 times 1 is 1. I still have this minus 2 up top here. 1 minus 2 is negative 1. Negative 1. All right. Now, because it's not a line, we can't just follow the pattern. We have to keep going. Okay, I'm sorry if you needed that work. Go ahead and rewind the video real quick. All right, last one I got to plug in is 2. So 2 to the third power minus 2. Again, 2 to the third power means 2 times 2 times 2. 2 times 2 is 4. Oops, I wrote the wrong thing. 2 times 2 is 4, there we go. And 4 times 2 is 8. I still have this minus 2. 8 minus 2 is going to give me 6. So that's 6. Now I got to plot those points. Okay, so I'm not sure if the axes showed up on your paper, but they didn't show up on mine. So I'm going to put them down the middle. Now I have to go to negative 10, so I'm going to go by 2's on the y-axis. On the x-axis, I'm just going to go by 1. So negative 1, negative 2, negative 3, negative 4, negative 5. On the other side, 1, 2, 3, 4, 5. Remember, 0 is in the middle. Going down, up and down, though, I'm going to go by 2's. So this is going to be negative 2. It's going to be negative 4, negative 6, negative 8, negative 10. Up top, 2, 4, 6, 8, 10. All right? So now I'm going to plot my points. I'm going to change colors so it's easier to see. So I'm going to go left 2, down 10, so I'm here. Then I'm going to go left 1, down 3, so like in the middle there. Then I'm going to stay and go down 2, so right there. Then I'm going to go right 1 and down 1, so in the middle, right there. And then I'm going to go right 2, up 6, so I'm up here. Now remember, we're going to draw a nice smooth curve through the dots. So it looks like I'm going to start down here. I'm going to like curve this way, and then I'm going to curve that way. So, again, it's continuing forever in both directions, so it still gets the arrows on both ends. And we look at it from left to right, and we say it's going up, because the graph goes up. From left to right, the function is increasing. Increasing, because it's going uphill. All right? Again, if you have questions on this, make sure you're asking, okay? Take your notes, take your video, go to Miss B. I'm sure she can help you figure it out. All right, last example. Example 3. Graphing a function that is described verbally. Okay, so now it's giving us a word problem. Okay, so it says consider driving a driveway that is 15 feet wide. Now, I don't know how many times I've told you guys this, but Miss Sheila is a visual person, so I'm drawing. That's my driveway. It's 15 feet wide. Okay? Graph the perimeter of the rectangular driveway as a function of its length. Is the function linear or nonlinear? Increasing or decreasing? Explain. Okay, so first we're going to write a function using the formula for perimeter, because that's what it wants us to graph. So if you aren't familiar with perimeter, that's the formula for a rectangle, 2w times 2l. Now here's the issue. Do I know what my length is? No. So I'm just going to let it be x. So plugging in here then, 2w, well w is 15, plus 2l is x. Okay, do a little math. What's 2 times 15? 30. 2 times x is just 2x, so I have 30 plus 2x. So there's my formula, right? I'd have p, or really this is y, equals 30 plus 2x. So now I'm going to plug in these numbers. Okay, let's change this to x. Let's change this p to y, so we don't get confused. So I'm going to plug those in for x. Okay, so I have 30 plus 2 times my first x it wants is 10. So that means 30 plus 2 times 10 is 20. 30 plus 20 is 50. So this first spot is going to be 50. The second number I'm going to plug in is 20. So I'm going to have 30 plus 2 times x is 30 now. Oop, 20. Sorry, I skipped one. 20. 30 plus 2 times 20 is 40. 30 plus 40 is 70. So the second number here is 70. Again, if you still need that work, that's fine. Just go ahead and pause the video for a second. I gotta erase it so I have some workspace. All right, there we go. Moving on, I have 30 now. So I have 30 plus 2 times x, which is now 30. 30 plus 2 times 30 is 60. 30 plus 60 is going to give me 90. So this is going to be 90. Plugging in 40 now for x. So I have 30 plus 2 times x is 40. 30 plus 2 times 40 is going to be 80. 30 plus 80 is 110. 110. Again, if you still need that work, that's no problem. Just go ahead and pause the video real quick while you get it copied down. All right. And the last one, plugging in is 50. So I'd have 30 plus 2 times x. X is now 50. 30 plus 2 times 50 is 100. 30 plus 100 is 130. So I have 130. Okay? So, graphing this then. Okay, notice I don't need anything below 0, 0, so I'm going to put my coordinates, or my axes on the edge here. And then I'm going to go by tens on the x-axis, so 10, 20, that's 0, 30, 40, 50, 60. Okay, on the y-axis, I probably should go by more, so maybe 20s. Yeah, that should be close. So 20, 40, 60, whoops, 60, 80, 100. Oh, not quite. So 30s, let's go by 30s. Okay, so 30. So 30, 60, 90, 120, 150. Okay, so I went by 30s on the y-axis so that they would all fit. So now I'm plotting my points. I'm going to change color so it's easier for us to see. So x10, so over 10, up 50, so like there. Over 20, up 70, so like there. Over 30, up 90, perfect. Over 40, up 110, so like there. Over 50, up 130, so like there. I'm going to connect all my dots with a line. And I know it's a line because, again, it's just 1x. There's no exponent up here. Okay, right? The invisible exponent would be 1. But since it's 1, we know it's a line. Okay, so as x increases by 10, so as this goes up by 10, my y is increasing by what? Oops. By 20. So the function changes at a constant rate. Changes at a constant rate, and therefore is a line. Okay, that's another way to know that it's a line. Because now I'm looking at the graph, because the graph goes up from left to right, I also know that the function is increasing. Increasing. All right? So that does finish it for these notes. You should go see Mr. Splickle now to get your assignment. And once you have your assignment, that's what you're working on for the rest of the hour. The second page of your assignment is just graphs for you to use, so you don't have to make the graphs. However, for some of the problems, you might want to change the numbering on the axes. That's totally fine. Okay, if you get stuck on anything, make sure you're asking Miss B. Otherwise, I hope you guys have a great day, a great long weekend, and I will see you guys on Tuesday next week. All right? All right, see you then.